this video, we're talking about how to factor the difference of two perfect cubes. So first of all, what do we mean by the difference of two perfect cubes? Well, when we say difference, we mean one subtracted from the other, so we need to have a minus sign in the middle, like we do here in this example. And then we have to have two perfect cubes, which means we need to be able to take the cube root of the whole term. So for example here, x cubed times y cubed, well, the cube root of x cubed is x because x times x, 3 times, right, is x cubed. The cube root of y cubed is y because y times y gives us y cubed, which means the cube root of x cubed y cubed, the whole term, is those two things multiplied together, xy. The cube root of p cubed is just p because p times p gives us p cubed. Both of these are perfect cubes and we have a difference. So we know we have the difference of cubes, and sometimes we want to be able to factor something like this. We want to be able to factor the difference of cubes. Well, whenever we do that, we're going to just follow a pattern or follow a process. It works every single time as long as we just follow the rules. So what we want to do as the first part of our pattern, we want to take the perfect cube of each of these terms. So the cube of x cubed is x. The cube root of y cubed is y. We always have a minus sign here as part of our pattern. And then the cube root of p cubed is p. So this is the binomial term that we're going to factor out of the difference of our cubes. Then we're going to multiply this by a trinomial, which means a polynomial with 3 terms in it. The first term is always going to be whatever we have to multiply by this first term here to get this first term here. So what do we have to multiply by xy to get x cubed y cubed? Well, of course, that's just x squared y squared. Then we're always going to add. This is always going to be a positive sign. Again, this is part of our formula or our pattern that we're going to follow every time when we want to factor the difference of cubes. So this will always be a positive sign. Then we're going to multiply these two terms together in this binomial. So we're going to multiply xy by p, and we're going to get xyp. And then as part of our pattern, we're always going to add again our last term here squared. So this term, p, we're going to square it, and we're going to get p squared. And that's it. That's how we factor the difference of cubes. We'll do another example and then we'll check ourselves. So with the second example, we have 64a cubed x cubed minus 27b to the 6th y to the 6th. Do we have a difference of cubes? Well, we know we have a difference because we have the subtraction sign in the middle. And is each one of these a cube? Well, 64 is the cube of 4 because 4 times 4 times 4 is 64. A cubed is the cube of a, and x cubed is the cube of x. 27 is the cube of 3 because 3 times 3 times 3 is 27. The cube root of b to the 6th is b squared, and the cube root of y to the 6th is y squared because y squared times y squared times y squared is y to the 6th. So we do in fact have the difference of two cubes. So we're going to factor the same way we did last time. We're going to take the cube root of each of these values. So the cube root of 64 is 4. The cube root of a cubed is a. The cube root of x cubed is x. Then we're always going to subtract. That's part of our pattern. We always subtract. The cube root of 27 is 3. The cube root of b to the 6th is b squared. And the cube root of y to the 6th is y squared. All right, so we factored out our binomial term. Now we need to multiply that by the trinomial the same way that we did here in our first example. So multiplying this by our trinomial term, remember we need to figure out what we have to multiply by this first term in order to get back to the original first term. So what do we have to multiply by 4ax in order to get 64a cubed x cubed? 64 divided by 4 is 16, which means we need to multiply 4 by 16 in order to get back to 64. We have to multiply a by a squared to get a cubed, and we have to multiply x by x squared in order to get x cubed. Now remember, we always add, and our middle term is going to be both of these terms multiplied together. So 4ax times 3b squared y squared. 4 times 3 is 12. We have an a, we have a b squared, we have an x, and we have a y squared. Then we always add again as part of our formula, and then we take the last term squared. Our last term here is 3b squared y squared. We're going to square it, and we're going to get 9b to the 4th y to the 4th. And now we're done factoring the difference of these two cubes. If we want to double check ourselves, we can always FOIL this back out. And in order to do that, we'll take the first term in our binomial, in this case 4ax, and we'll multiply by each of the terms in our trinomial. So 4ax times 16a squared x squared is going to be 64a cubed x cubed. Then we're going to take 4ax and multiply it by 12ab squared xy squared, and that's going to give us 48a squared b squared x squared y squared. Then we're going to multiply 4ax by 9b to the fourth y to the fourth, and we're going to get 36a b to the fourth x y to the fourth. Now that we've multiplied this first term by all three of the terms in our trinomial, we need to multiply this second term, including the negative sign, by the three terms in the trinomial. So negative 3b squared y squared times this first term here with the 16 is going to give us a negative 48 a squared b squared x squared y squared. Then we're going to take negative 3b squared y squared times this second term with the 12 in it. That's going to give us a negative 36 a b to the fourth x y to the fourth. Then we're going to take the negative 3b squared y squared and multiply it by this last term with the 9 in it, and that's going to give us negative 27 b to the sixth y to the sixth. So we've multiplied everything out. Now we need to see if we can combine like terms. Notice here that we have a positive 48a squared b squared x squared y squared and a negative 48a squared b squared x squared y squared. These two are going to cancel. That'll net to 0. We also have a positive 36a b to the fourth x y to the fourth and a negative 36a b to the fourth x y to the fourth. When we add those together, they become 0. And as you can see, we're just left with our first term, which is 64a cubed x cubed, and our last term, negative 27b to the sixth y to the sixth. And as you can see, we get back to our original problem, which means that we did our factoring correctly. So that's how you factor the difference of two perfect cubes.